Can we reconstruct a Neanderthal face from a skull? Yes and no. The honest answer is somewhere in between. Well, we can get remarkably close. We can build a face that is scientifically plausible, a face that belongs to the skull it came from. But we can't create a perfect photograph. We can't know for sure the tiny details that make a person unique. The process is a fascinating mix of hard science, forensic data, and artistic interpretation. It's a journey from a piece of ancient bone to a face that can look back at you. Let's start with what we have. The foundation for any reconstruction is the skull itself. A Neanderthal skull is not just an old human skull, it's distinct. It has a whole set of features that make it different from ours, from Homo sapiens. When you hold one, or even see a good cast, you notice these things right away. The brain case is long and low, sort of like a football, whereas ours is more rounded, like a soccer ball. They had a bigger brain than we do, on average. But the shape was different, which might mean their brains were organized differently. At the back of the skull, there's often a little bulge, something called an occipital bun. We don't have that. Then you look at the face. The first thing that hits you is the brow ridge. It's a heavy double-arched bar of bone over the eyes. It's not just a little bump, it's a prominent feature. Why they had it is a subject of debate. Was it for structural support against strong chewing forces? Was it some kind of social signal like eyebrows are for us? We don't know for sure. But it's there, and it dictates a lot about the upper part of the face. The middle of the face juts forward. This is called midfacial prognathism. It's as if someone grabbed the nose and mouth and pulled them out from the rest of the face. Their cheekbones are swept back, not prominent and forward-facing like ours. This gives their face a very different profile. And the nose. The hole in the skull for the nose, the nasal aperture, is huge. It's wide and tall. This strongly suggests they had big projecting noses. For a long time, the thinking was this was an adaptation to living in cold, dry climates during the ice ages. A big nose would have more surface area inside, with more mucous membranes to warm and moisten the frigid air before it hit their lungs. It's a plausible idea, and it guides how artists reconstruct this key feature. Their jaws were strong, the bone is thick, and they lacked a feature that is uniquely human, a chin. If you feel your own jaw, you have a bony point that sticks out at the bottom. Neanderthals didn't. Their jawline just curved back smoothly. Their teeth were also larger and more robust than ours and showed extreme wear and tear. We find scratches on their front teeth that suggest they were using their mouths as a third hand, maybe for holding hides while they worked on them. So, the skull gives us the framework. It's the architecture of the head. It tells us the width of the face, the position of the eyes, the size of the nose cavity, the shape of the jaw. This is the science part. This is not guesswork. These are measurements. A forensic artist starts by making a perfect copy of the skull, often using a 3D printer today. They study every bump, every ridge, every smooth patch of bone, because those details are clues. The next step is to add the muscles. This is where forensic science really comes into play. How do you know where muscles went on a 40,000-year-old skull? You look for muscle attachment sites. When a muscle pulls on a bone over and over for a lifetime, it leaves a mark. The bone becomes rougher, thicker, or develops a ridge in that spot. Forensic anthropologists have mapped these attachment sites on modern humans in incredible detail. They know that this specific rough patch on the jawbone is where the powerful masseter muscle attaches, the main muscle for chewing. They know where the temporalis muscle, another big chewing muscle, fanned out across the side of the head. The artist will take this knowledge and apply it to the Neanderthal skull. The Neanderthal muscle markings are often bigger and more rugged than ours. This tells the artist that their facial muscles were probably more powerful. So they begin to sculpt the muscles piece by piece out of clay or on a computer screen. They lay down the masseter, they add the temporalis, they add the small muscles around the mouth and eyes, the ones we use for expression. Each muscle is sculpted to a specific thickness, based on the size of the attachment point and data from modern human dissections. This part of the process is still heavily grounded in anatomy. We are building the engine of the face. After the muscles comes the next layer of fat, glands, and connective tissue. This is where things get a bit softer, scientifically speaking. We don't have fossilized fat. So we have to make an educated guess. We use data from modern humans. Forensic science provides charts of average tissue depth at specific points on the human face. There are dozens of these points, called landmarks. For example, at the center of the forehead, the tissue depth for an average European male might be 4.5 millimeters. On the chin, It might be 10 millimeters. The artist places small pegs on the replica skull, each one cut to the precise length indicated by these tissue depth charts. Then they lay down clay or digital skin, connecting the dots. It's like a topographical map of the face. But here's the problem. Are modern human tissue depths a good guide for a Neanderthal? Maybe. Maybe not. This is where inference and interpretation come in. A Neanderthal lived a very different life from us. They were highly active hunter-gatherers living in a cold environment. They likely had very little body fat, similar to modern elite athletes. So an artist might choose to make the face leaner, more sinewy, but at the same time, living in a cold climate might suggest a thicker layer of subcutaneous fat on the face for insulation. Which is it? The artist and the scientists advising them have to make a choice. They might look at modern indigenous populations living in Arctic climates for clues, but it's still an assumption. The resulting face might look gaunt and weathered, or it might look a bit fleshier. Both could be plausible. Neither can be proven for certain. Now we get to the features. The nose, the eyes, the ears, the mouth. This is where science provides a guide, but art has to fill in the final crucial details. The nose is a great example. As we said, the skull shows a huge nasal opening. This means the underlying structure for the nose was massive. We also know the nasal bones project at a certain angle. This gives us the general shape and size of the bridge of the nose. But the tip of your nose, the part that makes it pointy or round, or upturned, is made of cartilage. Cartilage doesn't fossilize, it rots away, so the exact shape of the tip of a Neanderthal's nose is pure, educated speculation. An artist can create a large, broad nose that fits the skull perfectly, but they have to invent the details. They might look at the nose shapes of people adapted to cold climates today for inspiration, but it remains an artistic choice. The eyes are a little more straightforward, but still have their mysteries. The skull's eye sockets, or orbits, tell you the exact size of the eyeball and where it was positioned. They also show the angle at which the eyes were set. Neanderthal orbits were large and quite round. So we can place the eyeballs in the skull with a high degree of confidence. But what about the eyelids, the shape of the fold, the thickness of the eyebrows? The length of the lashes? This is all artistry. It is guided by the underlying bone. The heavy brow ridge would certainly create a deep-set look, but the specific details are unknown. The mouth is similar. The width of the mouth can be determined by the position of the canine teeth. The shape of the dental arch and the jaw gives us the general structure, but the thickness of the lips. We have no idea. Were they thin? Were they full? Most reconstructions give them relatively thin lips, perhaps based on the assumption that full lips are an adaptation to hot climates, but this is a very weak argument. The artist has to make a choice, and that choice has a huge impact on the final personality of the face. Ears are almost complete guesswork. The bony opening for the ear canal tells us where the ear was located on the side of the head. But the external ear, the pinna, is all cartilage. Like the tip of the nose, it disappears. Most artists simply use a generic modern human ear. There's really no other option. It's a placeholder for a piece of anatomy we will likely never recover, so for decades this was the state of the art. A reconstruction was a sculpture based on anatomical principles and a series of educated guesses. The result was a monochrome clay bust. It felt real, but it was colorless. It lacked life. Then came the DNA revolution. Starting in the late 1990s and accelerating dramatically in the 2000s, scientists were able to extract and sequence ancient DNA from Neanderthal bones. This was a monumental achievement. For the first time, we had their genetic blueprint. And that blueprint contained clues that the bones alone could never give us. It allowed us to add color and texture to the reconstruction. One of the first big discoveries was about pigmentation. Our genes play a huge role in determining our skin, hair, and eye color. By analyzing the Neanderthal genome, scientists could look for the specific genes that control these traits. They found variants of a gene called MC1R in some Neanderthal individuals. In modern humans, certain variants of this gene are strongly associated with red hair, pale skin, and freckles. The specific Neanderthal variant was different from the one modern redheads have, but it likely had a similar effect. It produced less of the dark pigment eumelanin and more of the reddish pigment pheomelanin. This was a game changer. Suddenly an artist didn't have to guess the hair color. For at least some Neanderthals, there was now genetic evidence suggesting they were redheads. We also have genetic information suggesting others had dark hair and darker skin. This tells us that, just like modern humans, Neanderthals had variation. They weren't a monolithic, uniform population. Some were redheads with light skin, others were brunettes with olive skin. DNA can also hint at eye color. We can look for the genes that determine the amount of pigment in the iris. The evidence so far is not as clear-cut as for hair color, but it points toward a range of possibilities, including brown, hazel, and maybe even lighter eye colors. The genetic information adds a layer of objective data to what was once a purely subjective part of the process. An artist can now choose a hair and skin tone combination that has a real basis in the Neanderthal's own genetic code. It moves the reconstruction from plausible to probable, but we have to be careful. Our understanding of how genes create physical traits is still incomplete. We can identify a gene for red hair, but we don't have a single gene for nose shape or lip thickness. Those traits are polygenic, meaning they are influenced by hundreds or even thousands of genes working together, plus environmental factors. We are a long way from being able to look at a genome and print out a perfect 3D model of a face. The DNA gives us a few precious details, but it doesn't fill in all the blanks. This brings us to the final, and perhaps most important, ingredient in any reconstruction bias. The artist and the scientist are human. They live in a particular time and place, and they hold conscious and unconscious ideas about what Neanderthals were like. These ideas inevitably influence the final product. If you look at the history of Neanderthal reconstructions, you can see our own biases reflected back at us. The very first reconstructions from the early 20th century were based on a skeleton of an old Neanderthal man from La Chapelle-aux-Saints in France. This individual was suffering from severe arthritis. The paleontologist who studied him, Marcellin Boulay, interpreted his stooped posture and robust features as signs of primitiveness. He concluded Neanderthals were shuffling, ape-like brutes. The resulting reconstruction, a famous bust by the artist Charles R. Knight, showed a dim-witted, hairy, gorilla-like creature. This image of the caveman stuck in the popular imagination for decades. Boulay was wrong. The old man was stooped because he had arthritis, not because his species couldn't walk upright. But the reconstruction reflected the prevailing view of the time that Neanderthals were a failed, inferior side branch of human evolution. Now, look at a modern reconstruction. Take the recent work on Krine, a Neanderthal whose fossilized brow ridge fragment was dredged from the North Sea. Using the latest scanning technology, DNA analysis, and forensic techniques, the artist Adrian Alphonse Kennis created a stunningly lifelike face. This Neanderthal looks thoughtful. He has kind eyes. He has a slight, friendly smile. He looks like someone you could meet. He has a lump on his forehead, a benign tumor that the scientists identified from the bone itself, a detail that makes him feel like a real, vulnerable individual. What changed? The science got better, of course, but our perception of Neanderthals changed too. We now know they weren't stupid brutes. They made complex tools. They controlled fire. They hunted big game in coordinated groups. They cared for their sick and elderly, as the old man from La Chapelle shows. They buried their dead. They may have had some form of symbolic thought, creating simple jewelry from eagle talons and shells. They were not less than us. They were a different kind of human, living a different kind of life. The modern reconstruction of Krine reflects this new understanding. The artist made a conscious choice to give him an expression of intelligence and empathy. Is that expression scientifically accurate? Of course not. An expression is a fleeting movement of muscles. But it's an artistic choice designed to convey a deeper scientific truth that these were complex, feeling beings. So, the process is a constant dialogue between science and art. The scientist provides the data, the skull measurements, the muscle markings, the genetic information for skin and hair color. They create a zone of plausibility. The artist then works within that zone. They make hundreds of small decisions that the data can't provide. How weathered should the skin be? Should the hair be neat or matted? Should there be scars? What expression should be on the face? Each of these choices pushes the reconstruction in a certain direction. A face with scars and a grimace tells one story. And a face with clear skin and a neutral expression tells another. The artists are, in a way, biographers. They are trying to tell the story of a life based on the skeletal remains. Let's walk through it one more time, from start to finish. You have a skull. First, you create a perfect replica. Then you anchor the major facial muscles, sculpting them based on the markings on the bone. You use tissue depth markers from modern humans as a guide to lay down the flesh, adjusting for lifestyle and environment. You use the skull's anatomy to shape the bridge of the nose, but you have to invent the cartilaginous tip. You place the eyeballs in the sockets, but you invent the eyelids. You set the width of the mouth, but you invent the lip thickness. You put ears where the ear holes are, but you invent their shape. Then you turn to the DNA. If you have it, you can add a scientifically backed skin tone, hair color, and eye color. Finally, you add the texture of life wrinkles, pores, blemishes, and an expression. The result is not the Neanderthal. It is a Neanderthal. It is one possibility out of a near infinite number. If you gave the same skull and the same data to 10 different forensic artists, you would get 10 different faces. They would all share a deep family resemblance. They would all have the same underlying structure. The big brow ridge, the projecting midface, the large nose, the lack of a chin. But the details that make us recognize an individual would be different. So, can we reconstruct a Neanderthal face? Yes. We can reveal the fundamental Neanderthal-ness of their appearance. We can show people the face of another kind of human, a face that is both strikingly different from and hauntingly similar to our own. The reconstructions are powerful tools for connection. They take an abstract concept from a textbook and an extinct hominin and turn it into a person. You can look them in the eyes. You can imagine meeting them on a cold, windswept plain 40,000 years ago. But we have to be honest about the limits. The next time you see one of these incredible reconstructions in a museum, look closely. Appreciate the science that built the foundation, the careful measurement of the bone, the anatomical placement of the muscles, the genetic clues. But also appreciate the art, the texture of the skin, the look in the eyes, the subtle expression. That is where a modern human reached across the millennia and tried to breathe life back into the ancient bone. It's an educated guess, a scientific hypothesis rendered in silicone and paint. And it is the closest we will ever get to seeing them again.